Alright, so chapter 5 was trig stuff, more of the unit circle topics. In chapter 6, it says trigonometric identities, inverse functions, and equations. So we did a little bit of this trig identities in chapter 5. Those were the problems where you had to simplify them. We kind of struggled with those because we are not very familiar and comfortable using Carl, or trig identities. So you're going to have to keep Carl within arm's reach this chapter, because that's what we'll be doing today, is verifying trig identities. Also in this chapter we'll be talking about inverse functions. What does inverse sine, inverse cosine, inverse tangent, those things, what do they look like? How do I evaluate them? And we'll also be solving trig equations. So you'll have a whole equation with trig in it, not just the variable x, and you'll have to solve for x or theta or whatever it is. And you'll have to know the unit circle. You know, once you get down to sine x equals 1/2, you'll have to solve for x. You have to find what angle has a sine of 1/2, or evaluate the sine of 7 pi over 6, those sorts of things. All right, and there are some pretty in-depth trig identities in this chapter. We've only done the fundamental ones, the one in the upper left corner of Carl. But by the end of the chapter, we'll pretty much have used all identities on that sheet, and there are a lot of them. All right, so 6.1 is just verifying trig identities. This is easier than the simplifying. I talked about this earlier. It's easier because you know what the outcome is. You don't have to wonder whether it's simplified or not. You don't know whether to stop or keep going. Verifying means you've got this on one side, you've got this on the other side, and you're just trying to use trig identities to make this side equal to that side. You're verifying that this is equal to that. Before, you were asked to simplify this. So if you're going to simplify that trig expression, it may not be obvious where to stop. How do you know if it's completely simplified? Verifying, you know you're done when both sides are equal to each other. So that's what we're doing today. There are some guidelines. I've talked about this a little bit already in chapter 5. This I haven't used. The more complicated side, rule of thumb, use the more complicated side first. Like if you're given just tangent squared, waiting for the projector. There it is. I mean, how would you know where to start with that? But if you have all this is more complicated. You can start maybe by changing your tangent and secant in terms of sine and cosine. You can manipulate this easier than, it's not obvious what to do if you're just to the non-complicated side. So start on the more complicated side. Expand them or factor them. Write it in terms of sine and cosine. That's always a good thing to try. If you got numerator and denominator multiplied by the same factor, often the conjugate. I'll show you an example of that today. And you can actually work on both sides of an equation when you verify, but you can't do something to, you can't like take a +1 on one side and subtract it and move it to the other side. It's not an equation. We don't know that they are equal to each other. So imagine there's like a wall put up right like this. You can work on this side, you can work on this side, and if they're equal to each other, you're done. But you can't like divide by tangent here, divide by tangent. You can't do that to each side. You can just work on one side, or this side, or both sides, but you can't do something to both sides. All right, questions on that? So those are kind of the tricks. Really, if you're going to get good at this stuff, you're just going to have to do as many problems as you can. More and more practice. All right, so looking at this, we're going to verify that this is equal to that. So we have lots of different options. Okay, one thing to remember, I might do it differently than the way you do. As long as you perform legal operations, like I can change that secant x to 1 over cosine x. That's not illegal. I can do that. Okay, Some people may have done something different. They might have initially just changed this tangent to sine over cosine. Okay? Now, looking at this, now that I've done that, I can move that sine up on top, and I keep one eye on what my target is. I'm trying to write things only in terms of tangent. So it doesn't really make sense for me to change my tangent x to be sine x over x if we're trying to get to tangent squared. So I'm going to leave that alone, but I can move that sine x to the top. And what is sine x over cosine x? What is sine x over cosine x? Tangent x. Good. So now I have tangent x times tangent x. So I have tangent squared x equals tangent squared x. Your last statement should be this equals that, and you can put a check mark indicating that you've verified that this is in fact equal to that. It's not the only way you can do this problem, as I talked about, but it is a legal way. All right, another example. Okay, if I ever see two terms on top and one term on the bottom in math, I immediately consider separating the two fractions. Okay, and I would say that this is the more complicated side. So I would say this is the same as cosine x over sine x minus 1 over sine x. Let's see if that gets anywhere. Okay, so if you have 2 on top and 1 on the bottom, you can always separate the two into two different fractions. You cannot do it if you have 2 on the bottom. So if I have x plus y on the bottom and I have 10 on top, you can't say, well, that's, I don't even know how you do it, 10 over x plus 10 over y. That's not a thing. You can't, if you have 2 on the bottom, that's no good. If you have 2 on top, then you can separate x plus y over 10. That is equal to x over 10 plus y over 10. That's a good thing. All right, so back to this problem. I separated the two fractions. Now what? What's that?
The opposite tangent.
Isn't
the cosine x over sine x the same thing as opposite tangent?
Yeah, so very good. Sorry, it's the math I couldn't hear. So cosine x over sine x. That is what? We just said that sine x over cosine x was tangent x. So if you flip them, you get the reciprocal. So cosine x over sine x is cotangent x. And it's always a good sign that we've got cotangent x on the left side. Minus, and 1 over sine x can be written as what? The cosecant x. Very good. And we're done. And we can check it. We verified that the left side is equal to the right side. So what we're doing is, in the future, in math, it's just practicing the ability for us to rewrite trigonometric expressions. Okay? It's kind of like factoring or expanding. You're just rewriting in a different way. We're becoming more familiar with all the trig identities so that we can solve equations. And in calculus, you could potentially do integrals, derivatives, things like that. All right, last one I'll show you. Which side is more complicated?
Left?
I'd say left, yeah. I wouldn't know where to start 2 secant squared. So I have 2 fractions here. What do you suppose we should do with those 2 fractions?
Beat them up.
Did you say beat them up? What did they do to you?
They made me think.
Shame on them. Somebody said add or combine them. Very good. In order to combine fractions, you need a common denominator. So, my common denominator, they aren't the same thing, so I'm going to have to multiply this one by 1 minus sine x over 1 minus sine x. And this one by 1 plus sine x, if I can fit it in there. 1 plus sine x. All right, there we go. So I get a common denominator, I multiply this one by 1 minus sine x over 1 minus sine x, 1 plus sine x over 1 plus. So now their denominators are the same. I can combine them, so I have 1 minus sine x plus 1 plus sine x. That's my top, and the bottom is 1 minus sine x times 1 plus sine x. All right, we're not quite there yet. What do we think? What can we do? When in doubt, try something.
Cry.
Cry might help. This one where I should pause it before
Wait,
somebody
cross
answers.
out.
Is somebody actually going to answer?
Don't pause it.
You maybe pause it for 10 minutes.
Cross those out.
Cross what out? Can I cross these 1 plus sine x and 1 minus sine x's out?
Can't you?
You aren't the only one to think of that. No, you cannot do that because you're not multiplying on top, you're adding them. So
Oh.
if it was 1 minus times 1 plus, then you could cross them off. What can I do? Good, simplify the top. 1 plus 1 is 2. Negative sine x plus sine x is nothing. So I have 2 over. Should I do anything with the bottom right now?
Should we?
Okay, so if I left it as 1 minus, I have to do something with it because look on the right side. We got some work to do. It's somehow going to be secant squared. I don't want to go try to change secant squared into all this stuff. So let's try something on the left side. What could I do with the bottom? Yep.
Can you multiply the two by like?
Good. Yeah, we could FOIL it or we could expand it. Yeah, that's exactly what we should do. So we have binomial times a binomial. We're going to FOIL it. 1 times 1 is 1 plus sine x minus sine x minus sine squared x. All right, so I have 2 over 1 minus sine squared x. We are getting closer. We're trying to get 2 secant squared. We better ask Carl what to do next. I should have a Carl. My viewers probably don't know who Carl
You
is.
have a Carl in your head.
It all within arm's reach, right? This is Carl. And 1 minus sine squared. Anytime you see some trig functions being squared, combined with a 1 in them, look to the Pythagorean identities. There are 3 of them. Pythagorean identities are right here. So here's sine squared plus cosine squared equals 1. So we know that sine squared of something plus cosine squared of something equals 1. So if I was going to rewrite 1 minus sine squared, I'm just going to manipulate this a little bit. I could replace it with cosine squared. So it's now 2 over cosine squared x. And if I move cosine to the top, it becomes secant. So I have 2 secant squared x, which is what we were looking for. Now technically, you aren't supposed to be able to manipulate the identities. I am allowing you to do that. You can just kind of change these around a little bit and substitute what you need to. Questions on this particular problem or any of the problems? It's going to take practice. By watching them, it may make sense. By doing them, you're going to be stumped and think, what do I do now? And you might need a push in the right direction on occasion. But it does take some practice.